Hello everyone, let's learn anesthesia from basics. Today we will be discussing about basic physics in anesthesia, and the first topic in this is pressure. As an anesthetist, we make pressure measurements both in patients and in anesthesia machine. So it is essential to understand what pressure means. Pressure is defined as force applied or distributed over a surface. So we express this as pressure is equals to force per unit area, and force is defined as that which changes or tends to change the state of rest or motion of an object. Force is defined as which changes or tends to change or tends to change the state of rest or motion of an object, and the SI unit of force is newtons. So Newton is a force which, when given to 1 kg mass, gives it an acceleration of 1 meter per second. So Newton is kg per meter per second. Gravity acts on every object. So gravity acting on an object will give the object an acceleration of 9.81 meter per second. So for 1 kg, it is 9.81 Newton, and 1 Newton is equals to 1 by 9.81 kg, that is equals to 102 grams of weight. And SI unit of pressure is pascals. 1 pascal is pressure of 1 Newton applied over an area of 1 square meter. This is what Pascal means. But as we said, 1 Newton is 102 gram weight. It is very low weight. So commonly used unit for pressure is kilopascals. And in anesthesia machines, in oxygen cylinders, we also hear the term bar. 1 bar is equals to 100 kilopascals. This conversion is very important. And 1 bar is equals to 1 atmosphere. So when full oxygen cylinder shows a gauge pressure of 137 bars, it means it approximately has 137 atmospheres of pressure. And in anesthesia practice, we see this pressure and force relationship by using syringes of different capacities while giving the drug to the patient, and we'll write different scenarios where one is syringes while using the different volume syringes like 2 ml, difference between 2 ml and 20 ml syringes. Two, in a patient developing pressure source, and in pressure relief or pressure reducing valves. Let's see what happens when two different volumes of syringes are taken, and let's also consider the relative difficulty of injecting a liquid from large and from small syringe. The pressure developed in the syringe depends on the force and the area over which it is applied. Let's consider the force to be constant in both the syringes as 25 newtons, and the cross-sectional area of the plunger in 2 ml syringe is considered as A, and in 20 ml syringe as 4A. As we all know, pressure is inversely proportional to the cross-sectional area. The pressure developed in 2 ml syringe will be high, and the pressure developed in the 20 ml syringe will be low. Let's consider this as 500 kilopascals and this as 100 kilopascals. So, the pressure of 500 kilopascals is approximately 5 times the atmosphere pressure. So it is easy to produce extravascular infusion unintentionally with such a small syringe. Even though the pressure generated with 20 ml syringe is low, this is higher than the systolic blood pressure, which is 120 millimeters of mercury or 16 kilopascals. The pressure generated when local analgesic is injected from a 20 ml syringe can give rise to accidents during a technique known as intravenous regional anesthesia. In this technique, even though a blood pressure curve is inflated to above systolic pressure to protect the patient from the systemic effects of local analgesic injected into the distal vein. But from the calculations, we can already see that the pressure generated in 20 ml syringe is much more higher than the systolic blood pressure. If the vein is adjacent to the cuff, then there are high chances of developing intravenous regional anesthesia. Another example for this is the formation of bed sores in an immobilized patient. Suppose 20 kg is of patient's weight is supported by an area of 10 square meters, then the force generated is 20 into 9.81, that is 196 Newton, and the pressure is 196 by 10, that is 19.6 kilopascals. As we have already discussed, the systolic blood pressure is nearly 120 millimeters of mercury or 16 kilopascals. This 19.6 kilopascals, 16 kilopascals. As the systolic blood pressure is low compared to the pressure generated at the site, there is absence of blood supply to that area, leading to ischemia and bedsore formation. Pressure relief valve and expiratory valve, pressure relief valve and expiratory valves of anesthesia machine work on the simple balance between the force and pressure exerted over an area. Some important conversions to remember in this topic are 1 bar is equals to 1 atmosphere, that is equals to 100 kilopascals or 750 mm of mercury or 14.5 pounds per square inch. 1 kilopascal is equals to 7.5 mm of mercury or 7.5 torr, because 1 torr is equals to 1 mm of mercury. 1 Newton is equals to 102 gram weight. 7.5 mm of mercury is equals to 10.2 centimeters of water. Thank you for watching. Please like, share and subscribe.